In this video, we will introduce assertion usage available within the Java programming language. First, what would our code look like without assertions? Let's take a look at an example. Here we have in our main method a loop which breaks if the variable a is greater than 1. If the variable a is ever less than 1, then the program has a bug. We are anticipating and designing the code to always expect that the variable a is always greater than 1. If the code execution reaches here, then we have a problem or a bug. Let's run our code. The code is correctly executing. We are reaching here. Now let's make the changes to add assertions. We'll comment out this line and we'll add our assertion here. We'll copy the same message we were doing in our system.out print line. Now by adding assertions, you can have the advantage of quickly and effectively detecting and correcting program flaws, commonly known as bugs. Let's make a 0, and then let's run our code and see what happens. Code execution should not reach here. This type of assertion can be placed at any location where control will not be reached. This type of assertion is an example of a control flow invariant. There are various types of forms an assertion can be used for verifying code. There can be internal invariants, used to assert that a value is within a certain constraint, for example, 1 to 5. Class invariants, used to assert that an object's state is within a constraint, what must be true about each instance of a class before or after executing of a method. Class invariants are typically verified via private Boolean methods and a method called isValid to check if a circle object has a positive radius, for example. Control flow invariants used to assert that a certain location will not be reached, for example, the default clause of a switch statement. We already viewed an example of this right here in our code. Preconditions asserts that we must be true when a method is invoked, typically expressed in terms of the method's arguments or the state of its objects. Postconditions of methods assert what must be true after a method completes successfully. Let's look at a few examples. Internal invariants used to assert that a value is within a certain constraint. Let's create a variable here, x, and give it the value of 3. And we will assert that x is greater than 0. We'll be asserting internal invariants Now our assert statement that we make sure that a value is within a certain constraint. Now let's look at another type of assertion known as preconditions. Preconditions assert what must be true when a method is invoked. I'm going to make a method to illustrate it. We'll call it assertion example. And we'll pass in an integer with the name of a. And we will assert that this integer is greater than 0 and is less than or equal to 100. We will also define another variable which we'll use for a formula. Now we can see here that this assert precondition ensures that the variable passed in is within expected range before executing method logic. And we will consider this part method logic. This is an assertion known as a precondition. Let's continue and add our post condition, which asserts what must be true after a method completes successfully. We'll assert that B is greater than A, since we just added 2 plus A. This makes sure that our method remains correct after our method logic. Not only do we profit from assertions in development and testing, but also when our software is deployed into production. Assertions uncover error conditions much clearer and with better error descriptions. The logs in a production system will contain the messages from assertions and will help to find the cause of the problem much faster. If we switch off the assertions, the problems will be occurring much later, and cause the problem can only be found with much more effort. This concludes our discussion of assertion usage in Java.